weight shift control 3 components and systems. In the realm of electrical systems, weight shift control aircraft typically sport a 12-volt direct current setup. The basic configuration involves key components like the magneto, generator, voltage regulator, battery, master, battery switch, and associated electrical wiring. The battery stores electrical energy, serving as a power source for engine startup and various electrical loads. Activation or deactivation of the electrical system is facilitated by a master switch. In the on position, the battery supplies energy to electrical equipment circuits, excluding the ignition system. Common beneficiaries of the electrical system encompass position lights, anti-collision lights, instrument lights, radio and navigation equipment, electronic instrumentation, electric fuel pump, starting motor, and electric heating systems. Fuses or circuit breakers act as safeguards against electrical overload, protecting circuits and equipment. Spare fuses, matching the appropriate amperage, should be kept on board for replacement when needed. Circuit breakers, performing a similar role to fuses, can be manually reset in case of an overload. Placards on the fuse or circuit breaker panel specify the circuit names and their amperage limits. Monitoring the electrical system's performance can be achieved with an ammeter, indicating the adequacy of electrical power production by the magneto, generator, and the battery's charging status. A voltage meter provides additional insights into battery voltage. Introducing an extra layer of safety, some WSC aircraft feature a ballistic parachute system. This system becomes pivotal in scenarios of structural failure due to mid-air collisions or engine failures over challenging terrain. Activation involves a rocket propelling the parachute to full line stretch, ensuring a controlled descent. Preferably attached atop the wing's hang point, this configuration aims for a level descent, landing on the wheels to absorb shock. Alternative attachment points, like the mast and engine attachment points, result in a nose-down descent when activated. The ballistic parachute canister's placement varies, often mounted sideways on the carriage to avoid propeller entanglement. The actuation handle is conveniently located in the flight deck for the pilot's prompt use. Transitioning to the flight deck, the space where the pilot and passenger are situated, the tandem seating arrangement is common. In instructional setups, the instructor typically occupies the back seat with access to flight controls. The front pilot controls ground and flight operations, with foot pedals managing throttle and brake, akin to an automobile. Ground steering is facilitated by foot movement manipulating the front fork. For instructional purposes, an additional set of foot controls for throttle and brake may be included. A hand cruise throttle, when utilized, is typically positioned for easy access by both pilot and instructor. Ignition switches, crucial for operation, should be within reach, especially in instructional scenarios. The ballistic parachute handle must be easily accessible but positioned to prevent accidental deployment. Some aircraft have separate handles for the front and rear positions. Moving to the dashboard and instrument panels, these components provide crucial information related to engine, flight, navigation, and communications. The pilot, responsible for collision avoidance through visual scanning, relies on both external cues and instrumentation for informed decision-making. Ignition switches may be part of the instrument panel or within the instructor's reach. Dashboards vary widely, ranging from simple analog gauges to complex configurations. Analog gauges are common, but digital instruments gain popularity, particularly with light sport aircraft. Instrumentation requirements depend on the aircraft's classification, with no strict mandates for experimental LSA. However, special LSA usually requires an airspeed indicator, and specific engine instruments might be dictated by the engine manufacturer. The layout and complexity of dashboards are influenced by manufacturers and aircraft purposes, ensuring a diverse landscape in WSC aircraft instrumentation. Now, as we delve into the realm of flight instruments, it's crucial to lay down a foundational understanding of their operation, a knowledge prerequisite that can be found in the pilot's handbook of aeronautical knowledge. Among these instruments, one takes center stage, the altimeter. This unassuming yet pivotal device is our guide in the vast expanse of the sky, aiding us in maintaining the elusive balance of altitude during every phase of flight, from bustling airports to serene cruising, ensuring the safety of both pilot and aircraft. Now, moving our gaze to the vertical speed indicator, VSI, it stands as a trusty companion for the pilot, offering insights into the performance nuances of the aircraft. And, of course, we can't overlook the airspeed indicator, AC, a key player in our performance optimization strategy. It allows us to scrutinize the predicted versus actual performance, acting as a vigilant guardian to keep us within the predefined limits of our aircraft. Transitioning into the realm of navigation instruments, the ubiquitous global positioning system emerges as a reliable ally, serving not only as a navigation aid but also as a holistic flight companion. And let's not forget the magnetic compass, a stalwart navigator, ever ready to step in as the primary or backup guide, especially when the GPS takes a breather. Now, let's turn our attention to the instrument panels, the nerve center of our airborne vessel. Lays before us a standard instrument panel, a meticulously crafted arrangement from the manufacturer. Note the symphony of neatly arranged electrical components, the prominence of large analog airspeed and altitude flight instruments, and the essential engine instruments that give us a peek into the heartbeat of a simple two-stroke air-cooled engine. And speaking of engines, their instruments take the stage in ensuring our powerplant's optimal performance. The engine RPM, akin to the pulsating rhythm of our power source, is a fundamental indicator dictating the engine's prowess. For an in-depth exploration, we find ourselves in the realm of the powerplant section. As we ascend the complexity ladder, showcases an advanced analog panel. Look closely, and you'll find airspeed, vertical speed indicator, and altitude instruments gracefully adorning the top. Amidst this aerial symphony, a navigational gyro commands the middle, while the lower realm unveils the intricacies of four-stroke engine instruments, electrical components, and a user-installed radio and GPS, truly a cockpit adorned with technological splendor. Now, let's cast our eyes upon a hybrid panel marrying analog grace with digital prowess. Witness the harmonious coexistence of analog airspeed and compass indicators, dancing in tandem with separate digital instruments. The integration of digital panels, as depicted in unfurls a cornucopia of possibilities. Within this confined space, a plethora of screens, aircraft performance, engine systems, navigation, communications, and attitude indicators, unite to form a digital tapestry tailored to the discerning aviator. But flight isn't just about instruments, it's about communication, within the cockpit and beyond the clouds. Here, we encounter three communication systems within the WSC aircraft ecosystem. Firstly, consider the symphony of communication between the pilot and the passenger, an internal dialogue within the confines of the aircraft. Modern systems, equipped with advanced noise-canceling features in headphones and microphones, elevate this dialogue above the ambient roar of engines and rushing air. It's a nuanced dance between clarity and noise reduction, an auditory ballet that varies between systems. Thus, the discerning aviator is encouraged to explore, to test these systems and find the perfect cadence for their WSC aircraft. Then, there's the external conversation, the aircraft's dialogue with the skies. An aircraft radio, though not mandatory at every airfield, becomes a trusted ally when navigating the intricate dance of tower-controlled airspace. A simple push-to-talk button becomes our baton, conducting this symphony of communication. But in the intricate ballet of aviation, there's a third dimension to communication, the silent language exchanged between our aircraft and the control towers below. This is where the Mode C transponder takes center stage. At bustling commercial airports, especially those in classes C and B, and at altitudes surpassing 10,000 feet mean sea level, this transponder becomes our emissary. It sends forth a radar signal, a Morse code of sorts, articulating our precise location and altitude to the vigilant eyes in the control tower. Now, let's dive into the intricacies of the powerplant system, a crucial ensemble that propels our weight shift control aircraft through the skies. This system comprises the fuel system, engine, gearbox, and propeller, each playing a pivotal role in orchestrating our aerial dance. Starting with the fuel system, our WSC aircraft comes equipped with fuel tanks, typically holding 5 to 20 gallons of the elixir that sustains our journey. Unlike its ultralight predecessor, the LSA definition imposes no restrictions on the size of these fuel tanks. Positioned close to the center of gravity, CG, these tanks ensure that fuel burn doesn't disrupt the delicate balance of our airborne carriage. Some tanks, as seen in boast visibility for visual inspection, while others rely on fuel-level probes to communicate their contents. Fuel lines emerge from these tanks, incorporating essential components such as primer bulbs, fuel filters, fuel pumps, and, in some cases, a primer system. Venturing deeper, we encounter fuel shutoff valves and drain valves, safeguarding our system against water and contaminants. Now, let's shift our gaze to the beating heart of our WSC aircraft, the engine and gearbox. Engines come in various flavors, 2 or 4-stroke, liquid or air-cooled, typically ranging from 50 to 100 horsepower. Some sport electric starters, while others rely on the timeless pull start. Most engines in our realm feature reduction drives that deftly convert propeller RPM to a fraction of engine RPM, ensuring an optimal marriage between power and thrust. As we marvel at, we must acknowledge that a substantial chunk of our aircraft's weight is shouldered by the powerplant in its mounting configuration. Regular scrutiny of this engine mount becomes a ritual, a prelude to every aerial ballet. Now, let's explore the unsung hero, the propeller. Akin to a power converter, the propeller transmutes the raw horsepower of our engine into the thrust that propels us forward through the air. Whether adorned with 2, 3, or 4 blades, these aerodynamic marvels, showcased, are our silent companions in flight. Their pitch, whether ground adjustable or fixed, must be harmoniously set to ensure our engine operates at the recommended RPM during full power. Yet, with this marvel comes responsibility. Turning at dizzying speeds, a propeller becomes an invisible whirlwind of potential danger. Every pilot must exhibit the utmost caution and respect, for a rotating propeller brooks no carelessness. Debris on the airstrip, hard landings, or even a stray stone can morph into dangerous projectiles, threatening both the propeller and those in its vicinity. In closing, the powerplant system emerges as a symphony of components, each playing its distinct role. It's the fusion of fuel, engine, gearbox, and propeller that propels us into the boundless skies. As aviators, let's not merely view these as mechanical entities. Let's perceive them as the orchestral notes composing the melodious voyage of flight.